hi everyone. Where do we start? So basically, it's morning. It's very hard to me, and I was partying almost all the night, and my energy is kind of like really low. So I really need your help to raise the energy much higher than it's right now, right? It's in your power to do that, and I will deliver best presentation that I can in my condition right now. So there is always the bar of I like to say bar when you start to clapping and cheering, and when I rise the bar, the level, you actually start to cheering really louder and louder and louder, like screaming and stopping in the side. When I want the next stage, literally asking what the hell is going out there. So deal? Are we going to do that? Right, together? So let's start slow, clapping. Hey, no, come on guys. No, wait. We need to start low, right? So we start here, start. Come on, Woo! Yeah! Woo! Cool. So as you know, for a long time I was part of the GET. So yesterday I was talking about building startups, features, and the code is not important. Today I'm wearing different hats of developer, and code is important. The architecture is a significant part of your product. So here we're going to take today about the architectures. So I no longer work at Get. I just left to my own startup, and this has actually allowed me to experiment with different architecture and actually to build application from zero. And it's an amazing experience to create new issues and new bugs. And beside that, me and my partner Brit, you already saw her on the stage. We're actually leading the largest community in the world of Android developers. It's called what? Yeah, don't worry. So basically, we see tons of applications, really tons. Our students came to us with different questions: how, what, and what we need to do in order to make our application better, scalable, working on different devices, fragmentation, and all this stuff. And I thought, what could be the best output of this presentation, of this talk? And I really encourage you, and I asked Max to change a little bit the format, not to wait till the end of our conversation, of the talk, and start to asking questions, but asking questions now. So basically, we will have the microphones over the somewhere. So if you want to ask the question, I don't really see you because of the projector, but raise a hand, make some noise, and guys will bring you the microphone. Deal? Yes? No? Cool. I built a small application. I call it Star Wars Tinder because I'm so big fan of the Star Wars. So basically, you have all characters, and you swipe left and right, right? Everyone knows what's Tinder, I hope, or not. Or it's only me. Oops. There are some difficulties in the architecture, right? So basically, you have the list of the profiles, right, that you downloaded. You show to the user, and the user swipe. You're sending the like or dislike to the web server, right, in order to see if there's a match or to discard and remove it from profiles, right? And when you look on the architecture, and when I was looking at different applications, a lot of mistakes happen on it. So I brought you kind of piece of code, and I will walk through together with you about that. So basically, this code is living in activity. And it's someone click on the button, you create the retrofit client, you make a network call, right, with a response and two callbacks on response and failure. And for example, you create fragment, you update the database, or on failure, you're showing the dialog, right? What's wrong here? Okay, spaghetti code, right? But beside that, there's so many problems here. Who can spot it? I will give him a hug, free hug. Yes. Well, you need to... State laws, correct. Else? Right, not testable. What else? There are so many problems. It's like, it's oh, activity leaked, right? So basically, we have, once I have the client, wow. So basically, what can it possibly go wrong? Everything can possibly go wrong with this code. So we have this activity created, right? So that's, user click on the button, network start to work, and then we have this call and callbacks that waiting for this call to finish, and once it finishes, going to update our UI with the result, right? But what happened when I'm turn in the middle of the network call, I turn the screen and change the orientation. The life cycle is kicked in, the activity is destroyed, activity is leaked because there is a retrofit client that have a strong reference to the activity and still stay alive, and once the retrofit will finish the call and deliver the callback, it will try to update the UI. Will be the whole objects that they're trying to update will be still there, or going to be collected by garbage collector? Depends. So there's like trash, it's not testable, it's leaking the activity, and there is a lot of mess that happen in this code. So in order to make it work, actually not to make this a snake, and by the way, this is the code that from the application, very famous application, right now, I think 4 months ago, on the production. So you see how here the problems of dependency management, right? So we have new retrofit client every time user click on the button. The memory leaks, crash, status of the objects like stateless, code coupling, it's completely not separatable. And of course, because of this, it's not testable. And of course, it's like you can't really reuse this code. And what happened when our user clicked many times on the like button, right? So we have so many calls going out there, how you manage it, right? And what happened when you're in offline, that you don't have stable connection. And by the way, from my experience, from our statistics, even like I'm living in Israel, and Israel is like almost every place have 4G connection. But somehow, 20% of all calls ending in 500, sorry, not 500, like socket drop, that there's no internet. When it's happened, basically like you standing in the elevator, that's it, you don't have stable internet connection, and you just like someone on the Tinder. So you need to take care of it, right? Otherwise, it's the bad experience. And then Google guys released new Android architecture components. And actually, I think it's solving a lot of pain points that till today we developers were solving for ourselves. And like there's 200 different methods of recreating presenter or view model if you're using MVP pattern. And everyone was inventing something new. How you solve the lifecycle problem, how you solve the functionality problem, how you deliver the message, the data, the database, ORM, and other stuff. So Google released like 4 different libraries, and then 1 month ago they released the 5th one, the pagination, and today they also added the process lifecycling. So basically the 4 components, the more major components is, first is lifecycle, live data, and view model and room. And I will briefly cover them. I'm not going to show you a lot of code, don't worry. But like the whole idea of this talk is actually to show you an architecture that later you can explore at home. I hope for that you will open the code and just look what can you do with it, these components. And like modern applications have a lot of, it's always about the war between different architectures. So like there is someone will advocate for the RX Java, and someone say that, hey, we have in the Kotlin so many solutions, and like MVP is better, or like MVVM is better, Dagger 2, and clean architecture, and it's like so many different buzzwords, so many different architectures, so many different, the right thing to do. But showing so many different applications, showing so many different architectures and different stuff that people creating, I truly believe that there is no thing like one solution for everyone. It's always about who is developer and what is best for him. So basically, the best architecture is the one that you can easily understand to explain to others and make changes very, very quickly. Okay? This is the best architecture. It doesn't matter who's standing on the stage and who's declaring, well, everyone needs to use Dagger 2, everyone needs to use RX. It doesn't matter. What's the matter is how you, tomorrow, will sit at the office at home and doing your new feature, how will you feel about that, and how easily you can work with that. This is what's important. And don't buy things that people say on the stage. And most important is, as I said in my keynote, is actually you're building for the people. You're not building for yourself. It's not about the architecture, it's about your users. So if your application have an RX and Kotlin and or some Realm as an ORM, but it's not functional, really good, it doesn't solve really pain, it doesn't matter. It doesn't matter the beautiful code that you have inside your application. So build for your users and think careful what you're building. So when we're talking about architecture, I really like this approach of the offline first, right? So I really like the guy, the Iggy Boyar, is one of the developers in Android framework team, and he really like to quote, "Act locally, think globally." What does it mean? It means like instead of having every separate call going out there and say if it's failed, trying to do some with that, like to overcome this error, actually you're always using local storage for every of your call, everything that your user is doing on application, and then you're trying to sync it with the server. Okay? And I will show you what does it mean. So basically you have view, right? Activity, fragment, doesn't matter. And you have, like, we're using MVVM, so you have a view model, so view passing like action, that, hey, I'm ready to get the new data or whatever, and view model decide, okay, so if you're ready, you're the view, the one responsible for the profiles, so I will get to the repository and I will bring profiles. So instead of doing network call, actually what's doing the profile repository is going to the data access object of the profiles. And the data access object is actually making the select from the database, right, on the phone, locally. At the same time, the repository decide, like, okay, someone asked for the data. First, I'm going to bring the data that I have in my local storage. And at the same time, I will try to find and ask a network to bring the latest updated data, right? So it's going to the profile network data source and ask for the sync. And it's go to the API request, bring the profiles, and deliver it back. So like what happened back is like the database bring the profiles, profile repository bring the list of the profiles back to the view model, and then the view model actually delivering the result back to the view. And when the response is coming, it's not going directly to the view. Actually, it's going to the profile repository, and profile repository actually updating the database. And once the database is updated, only then we deliver a result to the view model, and then back to the view. This what doesn't mean to have to act locally and sync globally. The whole interaction is happening from the database, from the local storage. It not necessarily could be database, it could be any other storage that you can choose that's convenient for you. And using the Android architecture components that was released by Google, you can achieve this very easy. And I will guide you how you can do that. So basically, we have a couple of solutions I mentioned. One of them is Room. Room is a persistence library that actually it's a wrapper on top of the SQL. And it's using a couple of the components. It's using DAO. It's like data access object that actually generate the call code of accessing to your database, like how you access some certain tables, doing the selects. And then there's like entities, the POJO object that actually is stored in your database. Actually, this is the table. So in the code is looking like we have the profile, right? And in the profile we have a name, image URL, age, and like location, for example. So we just annotated that this is the entity, there's the primary key, and it should be null because it's the primary key, right? And the profile DAO is actually data access object. It's actually defining how I'm accessing to this object. So what's the methods they can use inside of my app? And as you see, it's a very standard one. It's like get the profiles, or like insert the bulk insert, or delete profiles. But most important is like when you query get profiles, you can actually, instead of just the data, you can get live data. And I will touch it in a moment, but it's very important. Okay, so instead of getting the list, you can get live data that allow you to do a lot of the stuff. And like as I said before, like you have a bulk inserts, you have a delete profiles that can delete for example, the whole table, or if you want to do like some count, like count number of names you have in the profile, count of the, and bring it back. To initiate this data, to create the database, it's just like you create the class, you extend from the room database, you specify version, and that's it. And you just hold the profile DAO that we created before. And then you just need to hold the reference inside of your application, and using this reference to access with a DAO object to your data in your entities, right? So how you hold this reference? Usually it's the best way to do this is like to have a Dagger time 2 that using its dependency injection dependency injection framework that you can use to hold reference for different ways. Like it can be singleton, it can be per scope for the activity and other stuff. So I just choose like to have room in memory. Just was lazy enough. It's like this is the example how you're using for the test. You can use database only in the memory, and then it's erased after the process is finished. And then actually I touched the live data component, right? The live data component is actually it's the object that the owner of lifecycle can observe, and it's have different states. The lifecycle, you know, it's bounded to the activity, right? So basically, lifecycle owners can observe what happening to the live data, and once there is no one to be observed, no lifecycle that is in a state resumed, then no updates is needed, and it's working like a charm. So basically, how it's look like, I have, for example, I want to subscribe to any changes in the database, and once like I go to the database, right? MDB is the reference to the database. I get the DAO, my data access object, and I'm asking for the get profiles. You remember what returning get profiles is live data object, right? So once I get the live data object, I can observe on it and any change actually that happen inside of this live data object. So basically, I put observe, I put this, it's actually the life cycle, and then I create the anonymous class that have only one method to implement, is like on change. So every time when I have something that updated inside of the database, I will get notified inside of my activity or fragment, for example, right? Also, it's not necessary to have lifecycle. You can observe forever. For example, you want something like, for example, some service that living during the whole process of the application. So you want to observe it for any change forever, as long as process is alive. So you just like observe forever. You call to this method, and again, you need just to implement the onChange method, and that's it. The another option of live data is to have the mutable live data. So like it's data that couldn't be changed by the user, not by the content, but literally to be changed. So for example, like if we want to provide the loaded profiles, we can just take the live data of type mutable and post values, and the someone that actually is listening for the change will receive these notifications about something that changed. It's very similar how React Java is working. So basically, you can also make in transitions, changes, and various of the callbacks, and it's really useful. So I touched the lifecycle component, and as I said, lifecycle component is actually it's abstract class. That every activity, every fragment is having it, and he has event and state. So basically, you can guess you're already familiar with that. It's not something new. Like the events is actually the lifecycle that happen, like on create, on start, and resume, and on pause, on stop, and destroy. And the event events is actually like when it's on create, so the life cycle is created. When it started, it started. Then when it's resume, its call is actually resumed, and then you start to receive all the updates. And back then there's like paused, created, and either. It's already part of the support library, so actually for you, you don't need to do anything. So if you're using support library 26.1 and either, it's part of the library, and you will get it for free. So if you look on the side of the implementation of the support library, you will see that every activity actually implements the lifecycle owner. And what doesn't mean is lifecycle owner is actually the one can provide the lifecycle. So if you want to write your own lifecycle, there is no problem at all. You just like say, okay, my object implement lifecycle observer, and you just need to annotate a couple of the methods, like at which state you're going to receive these events and what you're going to do with them. And you just add the observer to the lifecycle owner, and that's it. Let's skip it, and then actually the third component after the room live data is the view model. So the view model is just it's serving as dispatcher between the events that happen in the view, like actually the view delivering the events, and the view model actually passing them forward to the right repository. So it's kind of stores its UI. I thought I don't really like the idea, but usually it should do in this way. But with the live data, it doesn't store any data. It actually stores the reference to live data, and once the database is updated, it's obtaining the data from the database. So there is no need to really store the data inside of the view model. And it's really, I like the fact that it separates the various stuff, like from the view and the repository, and it's like guard. So basically, the only job that view model need to do is to react to UI events. It shouldn't have any state. It shouldn't have any reference to the view. You just need to have the events from the view and serve to ask the right person to do the stuff, like ask the right repository or like different repositories to do some stuff related to the action, and bring back from using the live data the things that happen. So how does it look? You have this component in the main activity, main view model, and when you're creating the activity, it's just like one line of code to create the view model. It's immediately available for you, and then you can subscribe yourself for the UI changes, as I showed you before, like get the live data from the view model and observe on any change of it. And so basically, this is how it's look. It's like get the view model, get the profiles. You remember this is the live data object, and we observe for any change. And actually, the view model itself, you just extend from the view model, and you can hold anything inside of it except the view. So I just choose to hold the reference for repository, the reference for the live data, and once the main activity view model is created, I get the injection of the repository that is right to use, and I'm asking for the repository, give me the reference for the profiles, right? Give me this live data that I will hold this reference, and if the activity will ask me to give me the live data, I will serve it to him. So basically, back to our solution. So this is what we did. We have the view model, we have the room to serve the data, and we have the lifecycle owners that will observe on any change. So basically, how the architecture is going to look is you have a view. A view is a lifecycle owner. And lifecycle owner actually he is creating the view model. And when the view model is created, it's creating the user repository, right? And user repository, immediately when they're creating, is also we have this user DAO object, actually a profile user that using room on top of it, and is connected to the SQLite. And once everything is ready, the next step is view is asking for the profiles, right, from the view model, the reference, and it starts to observe on any change. Put attention that I didn't put any reference to the live data inside of the view. I just asked to observe on it, right? It's very important step. Because in the moment where you will grab the reference inside of the activity, you just were going to leak the whole view view model, sorry. And basically, the user repository, profile repository, we're going to ask to load the profiles for the network. We're going to create inside our network data source the live data object, the mutable live data object, that our repository will observe on this live data object. And once we'll make a call for the network, and the network will return response, we will update our repository. So basically what's going to happen, we receive the response, right, from the network. We have this profile JSONs. And we're using the live data. You remember I showed you that mutable live data? So we're using like post update with the profiles. And immediately our repository will be updated with the new things, the new list of the profiles, without being actively asking or waiting for some stuff to do that we're going to be finished. And once the repository receives the update, we're going to update the database. So we're using the room, and we're just like updating the table. And at the moment when we update the table, you remember that in our view model, we grab reference from the database, right? So we get database, get profile DAO, get profiles, right? And we receive the live data. So at the moment when I updated the profiles in the table, immediately the live data object calling for all observers for our activity, meaning like our activity, and update it with the new users. Okay? And of course, you need to have some kind of sync service that doing it's on the background, right? So basically, every new update, you will like check the database for the new stuff that actually happened there. This is actually what you're doing today, but instead of that, like you will update the database using the different service, like job dispatcher will work, will finish the work, will update the user network data source, user network data source will update user repository will update the database, and immediately the change appear in UI. You don't need to do anything. You're just like observing for that. And if you want really to make it like offline completely, you also need to have like kind of push notification. So once you have a new data in the server, you just send the gong for your application, like, hey, I have new data. You can sync on background and just update the database to have it constantly be updating with what happened in the server. I'm not going to show you any code, or more than that, just to show, because it's like it's 1 second, because it's like more it's like digging in the details. I have it all ready for you in the repository. You can, but you need to make me a promise. You put the star on my GitHub profile. Yes, and this is time for the questions. And I will bring back the whole architecture. Yeah.
Okay, thank you for your presentation.
It's still not over.
Okay. So what happens if you get data from database and at the same time user updates some UI and request not finished yet? Does it will be closed those requests or not?
So the question was, if I correct me if I wrong, is like so I have request in the middle and still my database wasn't updated, right? And then user made some sort of request on the same table, right? If I can say, and how we solve this collision, right? New data from a source, like two sources for new data, and how I merge between them. So actually, what I did, I created this, I call it a merge resolver. So basically, it's a set of the rules. What can you have, like it's sitting in the user repository, and once you get update from the two different live data, is actually it's just comparing what timestamp from who is the owner of the update and what I like to do on the table or not. So basically, you have like the enum of types, and you just compare who can update or not, and if not, you just like kind of. But my suggestion to you: never bring error to the user. Like it's the most awful thing that you can get. Like if something went wrong, like deal with it. try to overcome in any sort of different way that will not noticeable for the user. And always, like, action that users did is the most important one. So if there is update coming from the database and they have a collision with what user did, user always win. Yeah.
Thank you for the presentation and for the approach you've given.
It's not over. You will not get me rid of so fast.
Thank you for the stuff that you already showed. Yes. So I have a question regarding the view stuff. So all the observers actually live in the activity because they're observing on the view models, on the stuff in the view models. So the question is,
it's not on observing on the stuff on the view model. They're observing on the live data.
Yeah, I mean it was observed this. So the activity is implementing the onChange method.
Right.
In that case, if I'll have, for example, 10 view models, really big view models, the main activity will grow so much. Can this be replaced somehow in the view model? So the view model will be sending kind of, I don't know, local broadcast receiving to the UI or whatever. Like the approach to make activity smaller.
So the approach shouldn't be like one view model per one activity or per one fragment. So, and your activity, it should be really, really small, like really small. It's only need to have an event and deliver these events to view model. And if you will see that your view model, the things that the view model is doing is growing, you're doing something wrong. Because others, for all this stuff, is actually the repositories are the one responsible. View model is just a dispatcher. You don't have the reference, and don't have state, you don't have data. Who will own the data is the database. So we have this reference to the database that through this reference you can access to the data, but view model don't own any data.
So the activity with the onChange method for every view model I have in the activity, I mean the reference to the view model.
There's only one view model per activity.
There's only one. The approach is to have one view model for activity.
Right.
Okay.
But you can observe on different live data objects.
Okay, I got it. Thank you.
Okay. So basically, you can have through your view model, you can have like 10 different live objects, and you can observe each one of them, and you will have different, or you can have one method on change, and just to distinguish between which live data you update you receive, or you can have 10 different anonymous callbacks. And in every one implement the onChange.
Hello, I have a question regarding entity of data access object.
Yeah.
Its fields are annotated with SQL comments. Why do we need them, and can we avoid writing them?
No. Avoid you can. It's like otherwise room would not working. Like this is how it's built. You need to have these annotations working and annotate properly your entities with everything that you expect to do, like keys, primary keys, foreign keys, like the all stuff that actually, basically how other way you're going to tell for the database, actually for the compiler, which code to generate.
Okay, what do I define name of the table? It's a name of the class?
It's in annotation when you create the entity, you can specify the name. Like it can use, by default, going to use name of the table as name of the class. But you can specify inside of the annotation the different name for the table. Actually, you also can specify different name for the columns. And the flexible of room is like, I don't think even about the case that you can implement inside of the room.
Okay.
The guy here in the front, we have only 2 minutes, so.
Okay, one more question. Does it work with Kotlin?
It's worked with the Kotlin. I thought there is some previous version that the annotation processing was broken. So be careful, like which version. But I suggest you just to look on the Stack Overflow, the Kotlin version, and the room, because there are some problems with annotations, and use the always latest version.
Okay, thank you.
I want to finish my slides. So basically, this is the guy that created, his name is Igor Boyar. He's the one that created our architecture components. And my point is, like, I just show you one of the architectures that you can use in order to support offline, in order to make your application much more robust. But real point that I made it at the beginning of the presentation, and I really want to finish with that, is actually you're the one that you need to make a decision. You're the one who need to make a decision which architecture is right for you. So if someone on the stage, like guy like me, said like, hey, this is the way, it's not necessary, like take it with a grain of salt, always double it. You have the whole power of deciding what is right for you or what is not, and like you need to justify, of course, what is right and why you decide this architecture over another one, and use it wisely. So we already asked the question. It's time to say thank you.